Now we got introduction to functions. So a function, this is nerdy, I think, kind of, but when every x value has only one corresponding y value. So it is possible you may see an x value twice, but as long as it has the same corresponding y value, that's okay. And this may happen both in graphs, in tables, it could happen in equations. I don't think we're going to see equations today. Or just lists of ordered pairs. Again, the ordered pairs may repeat, but it has to be not just the same x value, but the same y value that corresponds with it. If for some reason we see an x value, which is the output of a function, if we see an x value that has different corresponding y values as ordered pairs, we know that that is not a function. So y is a function of x. Oh, you're going to see this on the assignment. It's going to say this, y is a function of x. Y is what we call the output, x is what we call the input. I like to think of this as the old machines. They used to be animated, and you put a value in, and then it would put out some smoke, and then it would push something out, and that's how the function would work. I can't draw that well, so I'm not going to. But it's that idea. When you put something in, you need to know, in order for it to be a function, you need to know what's going to come out. Okay. So for example, just as an example, if I put a Hot Pocket into a microwave, okay, if I get out a pizza, I may be happy about that, okay? May not even be what I expected, but it happens, okay? And that would be okay. But if I go back and I put a Hot Pocket into the microwave, but out comes a burrito, are Hot Pockets burritos?
No.
I wouldn't classify them as burrito, but perhaps. Sorry, maybe that's a poor example. If I put in a Hot Pocket into a microwave and out comes a head of cabbage, I would be worried now, like, what the crap is going on here? I wanted a pizza, that's why I put the Hot Pocket in. I mean, you probably wanted the Hot Pocket out. This may be a bad example. Okay, let me do this with numbers because my real life example is horrible. If I put in a 2 and out comes a 4, then every time I put in a 2, I need to see a 4 come out. If I put in a 2 into the machine and then out comes an 8, I'm like, what the crap? You see what I'm saying? Now I don't know what to expect in the future, okay? So a function is just that. When you put in something that's x values, you need to know what comes out every time. If it's telling you something different is coming out, it's not a function anymore. Yeah, it's talking about domain and range, which we'll get into. The domain is a list of the x values, range is a list of y values. We may see these in interval notation or inequality notation as well. Okay, so these ones, again, are these functions. So I'm going to scan through the x values. If I don't see any x values repeat, I don't even worry about it. So this one, I got an x value, and that's 0, then 1. Oh, there's 1. It repeats. Okay, now we see that there's also a 7-11. I'm not worried about those. I just want to focus on the x values that are 1s. Well, when I put 1 in the first time, out comes a 3. All right, that's cool. That's fine. But when I go into the machine and put in a 1, it spits out a 9, and now I don't know what is going on right here. So this one, we would say, is not a function. And it is specifically for that reason. Okay, I put something in, something came out, I put something in, something different came out. That's not good. It's not functioning, whatever the machine is. The next one, we got -4, 0. So there's our -4 we put in. I don't see any repeats. Here's a 2 right there. Oh, there's another one, right? So right here, I put in a 2, out comes a 3. Over here, I put in a 2, out comes a 3. That's okay. That still is a function. All right, let's check the other values. Well, now it's a +4, out comes a 5. There's no repeats of putting in 4s. If I put in an 8, there's no other signs showing that something different would come out. Same with 15. So this one right here, a function. And just quickly going through these ones, don't let this trick you. We don't care what the y values coming out are. We care about what's going in, and then we can care about what's coming out. So right here, you put in a 4, 10, and 13. There's no indication that something coming out, if I put in a 4, that I'll get anything other than 5. Or if I put in a 10, something else comes out that's not a 9. So this one also a function. So if y values repeat, don't let that trick you into thinking it's not a function. It still can be like this one is. It ends up being the same thing for this one. So right here, I can see if I put in an x value that's 10, out comes the 9. Well, now when I put in a 10, out comes a 12. That's not functioning anymore. So this one also, not a function. Is the situation a function? A town's yearly population as a function of the year. So this would happen if for some reason you had a repeat of the year and then the populations were different. Now it's yearly population, so we're not looking at like the year and the month, okay? I guess that probably wouldn't even matter. But this one we would say is a function because once you get the population for the year, that's the population. Okay, so like for this year, 2022, you wouldn't expect the population to show one thing and then something different. What about a person's income is a function of their place of residence? So on this one, well, I'm going to specify on this one. A person's income, that's the output, right? On this one, the person's income is the output or the y, and then their place of residence is the x. So if you see a place of residence, would you expect the income to be different? I guess not if you just looked at one specific time, okay? Because this one, I would say, is also a function. A person's income. Now, you may say, well, there may be more than 2 people that live there that have different incomes. That's true, but we're looking at one individual person's, not persons'. The number of kilometers ridden is a function of the average rate of travel. And again, this is saying that your output is the distance and the input is the average rate of travel. So is it possible to have an average rate of travel? Let's just make up one. Like, I'm going to go 100 miles per hour because it feels good. I shouldn't admit that on video, but input. If I go 100 miles per hour, is it maybe I should say kilometers, but miles per hour, is it possible to travel different kilometers, different distances?
No.
So I may be making more difficult than it needs to be. And they kind of jacked it up with the kilometers, but is it possible for me to travel going 100 miles per hour? Is it possible that I could just go maybe 100 kilometers? Now let's think that I could, right? I could just stop. I could just stop at 100 kilometers, right? So I could say 100 miles per hour, and then I would drive 100 kilometers, I guess. But could I stop at 50 as well? Driving 100 kilometers per hour or miles per hour, could I stop at 50 kilometers? The answer is yes, I could. But now we have an input that gives us 2 different outputs. And so this one right here is not a function. Function graphs, all we're going to use the vertical line test. And it's as easy as it sounds. All you're going to do here is you're going to take a vertical line, we'll pretend like that's exactly vertical, and you're going to scan the shape or the line that's graphed for you, okay? Now the thing is if the line goes through this vertical line more than once, if it ever touches it more than once, it is not a function. And the reason that is because you'd have an input that's the same, but now you have outputs that are different. So I put those 2 points to show that maybe that's a crappy example, but it has nothing to do with the straightness of the line or the curviness of the line. You can have a curved line that is still a function. Oh, I need my vertical line again. So I'm going to take this vertical line. We'll pretend like it's exactly vertical, and I'm going to scan this. So I see it goes through this point right here, but it's not touching anywhere else. Same here, 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 and here. So this one would be a function. And let's take that vertical line and try this one. So I'm scanning, now it's a line. I'm just looking for it to cross more than once. It never did. So this one also, a function. Okay, how about this one? Scanning, it's good, it's good. Nope, not anymore. See that right there? Now it's going through 3 different points. So this one is not a function. All right, and then this last one, scanning, scan. Oh, there it is. Didn't even have to scan for very long. We see right away that this one is not a function. You may even say, well, if you scan the other ones, it doesn't. But yeah, it doesn't have to be everywhere. It just has to happen once. That's it. So it happened once, not a function. Function notation. You may see it like this, f of x. F of x is just another way to say y. Now, you see I read this as f of x. That's because mathematically it reads f of x. And hopefully in a math class, when you see this from now on, you would read it as f of x. They may use different letters though, something like this. But again, it still reads the same, g of x. They may not even use x, they may use t. And then you got g of t, okay? So this is telling us that y is a function that depends on x. Y is the dependent variable, x is independent, meaning it just is all by itself, and the y will change based on whatever the x value represents or is. So yeah, this example, f of negative 12 means that x is negative 12 and the function is relying on this value. You may replace x with the equation. Yeah, this is telling us that whatever the equation is, you can replace the x with this negative 12. X is negative 12. That's what it's telling you. But when f of x equals 9x plus 2, evaluate f of 3. Remember that this right here is telling us that x equals 3, right? Because it really is supposed to show f of x, but it's now f of 3. Replace the x with 3, right? So we're going to show this as f of 3 equals 9, but now the x is replaced with 3 plus 2. I wouldn't do this with the order of operations. I just put it in the calculator. 9 times 3 is 27 plus 2 is 29. Boom. By the way, this creates what we would consider an ordered pair, 329, which then would allow you to graph an ordered pair for this equation because we have both an x and y value. All right, well, what about these types? I like f of 0. We'll get to that one. But first, we got f of negative 2. Again, this is just telling us that take your x's and replace them with negative 2. So we got 8 times x, which is negative 2. It's negative, so I do want it in parentheses, minus 2 times negative 2, and then plus 3. But again, I'm just going to put this into the calculator, and then I'm going to call it good. Yeah, I got 39. So again, this would just be an ordered pair that you could graph negative 2, 39. But again, just let the calculator do that work for you. This next one's not too bad. Oh, crap. Let's go back here. Let's go back to the original equation, though. Once again, 8x to the power of 2 minus 2x plus 3. But again, it's f of 0, so that tells us replace your x's with 0. So that's what we will do. Now, like I said before, 0 is a pretty easy number to work with. I know anything times 0 is 0. And this one, pretty quickly, we can see f of 0 is positive 3, which again is the ordered pair 0, 3. And that would be our y-intercept. If f of x equals 2/3 x minus 8, determine x when f of x equals 13. So this f of x right here, I'm going to replace it with this. It was negative 13. And then I'm going to solve the equation. So some principles of equality are in order here. Let's start with getting rid of that negative 8 by adding 8 to both sides. So that'd be negative 5 equals 2/3 x, and that zeroes out, just as we would want it to. And then next up, oh crap, whatever. I'll get rid of it later. Next up, let's make that 2/3 of 1. So principle of equality, divide by 2/3. Divide by 2/3. That will make it a 1x, like we would want. That's going to give us negative 15 halves, or negative 7.5. And you could, well, I guess we can't check that, but that tells us the x value. So now I guess that's all they wanted. I was thinking of the ordered pair. It would be negative 15 halves, negative 13. All right, these ones I think they go faster than probably you'd want, but this again, it's saying find f of 5. That's the x value that's 5. So I go through this table. I see x is 5 right here. Its corresponding y value is negative 17. That's it. And of course, that would be a box that you put in on the assignment. Next up, it says f of x equals 24. That's really y equals 24. And f of x there is y. So I'm just looking in this row for 24. It's at the very end there. its corresponding x value is 9. So that means that would tell us that its corresponding x value is 9. Or it would be the ordered pair 924. And it's the same thing. That last one was on a table. Now we're on a graph, right? So again, I'm looking, it should be f of x. So I'm looking where x is 2. X is 2 right here. I just need to find the point on the line. Boom, it's right there. Its corresponding y value is 3. Which again, that is the ordered pair, 2, 3. Now I want to find the y value where it's 2. So this y value 2, I want to find where it is on the line. Boom, it's that point right there, which appears to be at negative 4, 2. And so the x value that corresponds with that is negative 4. In the expression that it gives you, or the equation like it did the second one, it's telling you what to look for. If it says f of x, you're looking for the y's. If it says f of some number, you're looking for the x, just like on those last ones. So domain and range, domain's list of the x values, range is the list of the y values. Solving equation, we ended with one answer. So this goes back, when we're solving equations, generally we're just looking for an x value, but of course now we're looking for possibly two values, x and y. Oh yeah, so, and we talked about this. Now when we graph, the line represents an infinite number of values that if you were to make them ordered pairs, would make the equation true. And that's the nice thing about seeing two variables in an equation like we would with y equals mx plus b. Hopefully that one seems familiar. The interval notation, it shows a range of solutions for an equation. That's true, we just want to see the solutions. Sometimes though, we may use inequalities to show values that don't work, and that's fine too. You'll need to remember though that if you're using parentheses, that it tells us values that are not included in the range or domain, which means they would make the statement false, but it also tells us where it transitions from being false to being true. The same thing is true with these ones, the square brackets, but that tells us that the ends are actually valid. They make the original equation true. So values can go to negative infinity as well as positive infinity. If that happens, we just have to use parentheses with infinity. So yeah, we use parentheses since those values are not included. Hopefully it will once we get started. For a domain and range on graphs, if we have to graph them mostly, we'll use interval notation to express the domain and range. But if we do, we still may use the graphs to do it. On graphs, just in case you don't remember, if we use the square brackets, it means it was a closed circle. If we use regular parentheses, then it was an open circle. If we're just listing a set of values, then we'll use these fancy brackets, which we may use for set notation as well. So right here, find the domain and range. We already hit, well, hopefully remember, because we just saw it a couple slides ago. Domain is the x values. And the range is the y values. So the domain, don't worry about the shape of the line necessarily, but we do want to see for the domain, we're really looking to the furthest left point and the furthest right point. We're looking left to right, okay? So I don't care that it goes up and down for my domain. So how far to the left does this thing go? I can see it goes as far to the left as -5. So the furthest to the left we can go is -5. The furthest to the right we can go on this line is over here to 1, right? So that's my interval right there, which I think it wanted. And we can see over here at -5, it's an open circle, which means -5 is not actually part of the domain, but everything to the right of it is until you get to 1. Then we have the closed circle, so we're expecting to use the square bracket. Now again, this is an interval. It is not a ordered pair. So this tells us that everything between -5 and 1 is good, and then the endpoints, -5 is no good, 1 is good. And just again, -5 is not included because it's open. If it's open, that is how we communicate mathematically that is not included in either the domain or range. So the range is just Y values, so we're looking at up and down. Okay, how far up and down does this thing go? Actually, you should start with down, because that would be the furthest to the left. Well, to the down, this goes as far down as -3. It goes as far up as +3. Okay, but again, are these endpoints included? Well, the -3 is not included because it's an open circle, so that's an open bracket. The 3 up here, though, is a closed circle, so it is a square bracket. I just want to emphasize this. If this line in between here had gone all weird like this, it wouldn't matter. That would not change the domain or the range. So yeah, this one, it's pretty funky, right? The domain and range. So the domain is my X values. So I can see the furthest to the left point I have here, it goes as far to the left as -4. It is a closed circle, so I'm going to include that in the domain. The furthest to the right it goes is 5. So I got a comma 5. It also is a closed circle, so it's another square bracket. Now, the domain here is on the endpoints to the left and right. The range is not. You can see the range goes as far down here. It's going down and then back up, and then it ends at this point. So this value right here, -4, is as far down it goes. And yeah, that point would be part of the graph, so it is included. And then it goes as far up here as, well, 0. But again, that line is actually touching that corner, so it would be included. And that is our range. This goes back to every point on this line would make whatever the function is true. And so this point is actually going through the origin. And so we have to include the 0 in the range as a square bracket. I'm trying to think, if they wanted it to not be included, they'd still have to show like an open circle at that point, wherever the top or bottom is. All right, so this one, it is a list of values. And so I'm going to have to use the fancy brackets here. If you're not sure how to do fancy brackets, it's not too bad. Just do an S to open it up, and then a 2. That's kind of a crappy S and 2, but I'm still okay with it. Now, it doesn't matter which order you list these in, okay? So I'm just looking for the X values for the domain, right? So I can see that this point right here corresponds with -6. And I'm just working from left to right. That's going to put them in the list from least to greatest, but you don't have to. This point corresponds with the next value that's -4. This one corresponds with the next value that's -2. This one corresponds with the next value that's 1. And then finally, this point corresponds with the next value that is 2. Then we need some fancy brackets to close that. And so it's a 2, then an S right there. That one turned out better. Now here's the thing, is on a test that's written, if you do not show fancy brackets, minus a point. Next up is the range. So I'm going to open up a square, some fancy brackets. So there's an S, there's a 2. I don't know if that's better, but I'll still take it. I'll start with the bottom again and move my way up, so I can see the lowest point there corresponds with the Y value that's -8. Next one, that's a -7. Sorry, those are kind of small, but I can barely see them. The next one I see corresponds with the Y value that's 4, and then a +8, and then finally a +9. So I have listed these in order from least to greatest just because of the order that I went in, but you don't have to. And then again, closing the bracket, it's a 2, then an S. That's a crappy S, but I'll still take it. Find the domain and range of this one. So the domain is just all the X values, and I can see them all as the first values there, right? Let's kind of go in order there. So the domain, -5, -4, -3, -2, 11, and then 13. I'm just listing all the X values. I listed the values, so I do need fancy brackets. There's an S, there's a 2. Close fancy brackets. I knew that one over. 2, then an S. There's my domain. That's all I need. Now, in the range, we can see that values are going to repeat, so I'll open up the brackets this time. But I got -9, and I got 4 sets of them. Never list values more than once if they repeat. So I have 4 -9s. I only need to put 1 -9 in the range. That's it. Then we have the other values, 19 and 99. Lots of 9s there. Then close it. 2, then an S. So again, if you do list, if you were to list 4 -9s on the test, I have to take a point off. So please don't do that, because I don't like doing it. Now, is it a function, though? Yeah, it is. Very good. Because, well, I don't see any x values that repeat, so I don't really care what comes out. Even though the -9s repeat, doesn't matter. It's the x values that we want to see if they do repeat. So yes, this one is a function.